Chapter 6, Hacking AI and Building Algorithmic Literacy. Quote, "To really try to be informed and literate today is to feel stupid nearly all of the time and to need help." Unquote. David Foster Wallace, The Best American Essays, 2007. We've covered the basics of intelligence, tools, and people. The rapid evolution and advancement of AI will start to enhance each of these individual domains. This means supply chains will benefit from new ways of AI-generated intelligence and tools. However, we can't take advantage of these benefits until we better understand how these algorithms work. Listen to any analyst, pundit, or consultant, and they will continually reference algorithms. Every time I hear this word, it tickles the curiosity part of my brain. What or who is this algorithm? Is it a mathematical equation? Is it an executable program? Is it sentient? Or is it something else? If it exists to improve operations, forecasting, routing, allocations, then who's in charge? Who understands the responsibility? If we're going to build the next generation supply chain, we need to grow a greater algorithmic literacy individually and within our teams. Increasingly, algorithms control our lives. If you use a smartphone, social media, e-commerce, take public transportation, drive a modern car, or have countless interactions with smart devices, you are encountering algorithms. A cynic might say we are manipulated by these algorithms. Algorithms are a crucial component of understanding AI. Thus, we need to understand how algorithms work, what they can and can't do, and how they can be manipulated. We must desensitize ourselves from the hype so that we can learn and use these very powerful tools. I have 3 friends that are algorithms. I know that sounds weird and a tiny bit sad, but hear me out. I rely on my first friend, the YouTube algorithm, to teach me and build my intellectual curiosity by suggesting helpful videos. We tend to trust recommendations from our friends. In my case, some of my closest friends are mathematical. Okay, that does sound sad. As we saw from my data tracking exercise above, I spend 30 minutes each day watching videos. I don't actually search for videos anymore. When I first started procrastinating on writing this book, I watched a few initial videos about Amazon Web Services, logistics in the Arctic, and problems with corporate sustainability efforts. Since then, the algorithm has taken me on a wide and vast journey of recommendations that have helped me learn about the rise or fall of particular brands, how Amazon delivers packages to aircraft carriers deployed at sea, cybercrime, private equity, and all kinds of other random yet interesting and informative videos. I've learned a tremendous amount of knowledge in a very short time simply by letting the YouTube recommendation engine learn a little bit about my interests. And yes, I do examine the content creators and validate their credentials as experts. My next friend is the LinkedIn algorithm. As an influencer, I rely on it to promote me, to put my content in people's news feeds, and to recommend it to the proper people. It also gives me the latest news and activity about the people it thinks I need to know. This is a time multiplier for me. Finally, the Facebook algorithm talks to me. Don't worry, it's not a two-way conversation. That would be weird. When I transitioned, I deleted my old profile. It was anchored in anger and ego. Post-transition, I created a new profile with only a handful of friends, 78 as of this writing. I hardly post anything and rarely send messages. But I watch how every interaction influences the next. I add a Jewish friend and all of a sudden, I get a whole series of recommended friends who are, you guessed it, Jewish. I click on a vegan ad and guess what? I start to see all kinds of vegan ads in my feed. I watch a recommended inspirational video and sure enough, I see many more inspirational videos. As I interact with Facebook, the algorithm talks back with new and different content, suggestions, and recommendations. It is that response from the algorithm that intrigues me. You could say I'm hacking these algorithms, but really I'm simply reverse engineering them to get what I want. Chloe Zhao's film Nomadland explores the plight of itinerant older workers as they follow short-term employment throughout the year. Some of their work includes time in Amazon fulfillment centers as part of Camper Force, part of Amazon's seasonal hiring program for people who live in recreational vehicles. What Zhao highlights is that for workers in these warehouses, Their world is centered around handheld scanners. These scanners tell them what they need to do and where at any given time, and most importantly, how much time they have to complete the task. The managers have no control over what the employees are doing. The oversight comes from the nameless, faceless algorithm. In reality, it is probably much more of a series of programmatically embedded algorithms within a custom software application. Obviously, the mechanics are proprietary. The stark contrast between this algorithmic way of working and the past manager-centric control is worth noting. Since the advent of industrial operations, the manager has been responsible for what happens on the shop floor, ensuring the workers' productivity, the quality of the products, and the efficiency of the operations. What happens when the manager is no longer in charge, but instead a dislocated cog in relationship to the machine? As Zhao notes, the manager can have a caring relationship with the employee because the algorithm is the culprit or villain behind anything that goes wrong. In China, gig workers are directly confronting their algorithmic overlords. An estimated 200 million people work in the gig economy there. Increasingly, tech platforms have improved their algorithms to push workers to reduce delivery times to increase profits. Some of these changes include incorporating gamification so that workers are pitted against one another to compete for various statuses, brown, silver, gold. The higher the achievement, the more the take-home pay. Naturally, an increase in worker accidents and deaths has followed. In response, these workers have gamed the algorithm by banding together to share information and modify collective behavior. For example, using social media platforms like WeChat, workers will collectively reject orders for difficult areas, known as, quote, no-fly zones, unquote, until orders come back with a higher price. They are hacking the way the algorithm operates to improve their working conditions. Workers will also create fake orders to improve their standing within the algorithm. How are we putting more faith and control into algorithmically controlled systems without fully understanding them? If this book were more of a social commentary, I might point out that algorithms used in policing rely on historical crime rates, location data, and demographic, such as socioeconomic background, education, and zip code, data to predict future crime. In the process, they perpetuate systematic racism because the data used to train these algorithms weights arrest rates higher than other factors, and that black people are 5 times more likely to be arrested than white people. I might further point out that a predictive policing algorithm should weight conviction rates or severity of crime higher than arrest records. After all, being arrested for protesting at a Black Lives Matter rally is far different than defrauding the federal government of millions of dollars. The problem is that the algorithms rely on statistics which prioritize frequency, so the algorithm skews towards high-frequency, low-impact events, such as arrests, versus low-frequency, high-impact events, such as fraud convictions. We are rapidly entering a new phase in the digital era as China has started to regulate algorithms with its provisions on the management of algorithmic recommendations in Internet Information Services of March 1st, 2022. Within these provisions, the Chinese government is forcing tech companies operating in China to be accountable for how their algorithms behave. According to the policy, the providers of algorithmic recommendation services, 1. Must not set up algorithmic models that violate laws and regulations or go against ethics and morals, such as inducing users to become addicted or spend too much. 2. Must not use algorithms to register fake accounts, making excessive recommendations, manipulating the order of top content lists or search results, or controlling how searches or selections, influencing online public opinion, or evading oversight and management. 3. Must not use algorithms to unreasonably restrict other Internet information service providers or to obstruct and undermine the normal operation of the Internet information services they lawfully provide, implementing a monopoly or unfair competition. 4. Shall provide users with functions for selecting or deleting user labels used in algorithmic recommendation services that target their personal traits. 5. Provide work coordination services for laborers. They shall protect the laborer's lawful rights and interests, such as to receive salary and to rest and vacation, and establish and improve algorithms related to assigning orders, salary compensation and payment, work times, rewards, and penalties, and so forth. The EU and UK are enacting similar legislation. This is a logical step as we have national and international systems to govern land, air, and space and water. We are entering the phase where cyberspace is becoming regulated. Case in point, America's Biden administration released an updated cybersecurity strategy proposal that will attempt to hold software companies liable for failing to put proper levels of security controls in their code. As consumers and global citizens, we must take a much more active role in understanding how these systems work, since increasingly they control and manipulate our lives. Algorithms shape how we shop, the media we consume, the news we ingest, how our retirement accounts are invested, and much more. Given the importance, programmers, engineers, and the companies that develop these algorithms need to be able to explain how they work to lawmakers, regulators, and the public. A loose understanding of how an algorithm came to an answer isn't enough. So as we think about building the next generation supply chain, one that at its core is driven by intelligent algorithms, we need greater algorithmic literacy. Machine learning, the basics. What if I told you the next generation supply chains will be run using 12 algorithms? Would you agree, disagree, or counter? Do you have a guess? I don't actually know, and right now nobody does, but that's the point. If we're going to talk about how AI or algorithms in supply chains, we'd better find out the answer, and pretty quick. Here's a brief non-technical primer on algorithms to start the exploration. Please note there are classes, books, and undergraduate and graduate programs that study the discipline of machine learning and related algorithms. What I'm doing is providing the simplest definition so that we can collectively understand how all of this magic works and apply it to building the future supply chain. Also, this is all changing very rapidly, and by the time this book goes to print, it's likely there'll be a new set of breakthroughs in this realm. Ultimately, if I get anything wrong, remember, I'm a historian by training, not a mathematician or a computer scientist. According to computer scientist Hilary Mason, machine learning teaches computers to recognize and learn patterns from data and apply them to new things they haven't seen before. This is accomplished through an algorithm, which is a set of steps that takes input data, processes it, and outputs new data. In succinct terms, machines are good at detecting patterns. For example, they are particularly good at looking at historical patterns to predict the future. This is called regression and is often used in forecasting and demand planning activities. Under the machine learning umbrella, there are 7 basic concepts to understand. And if this is the only takeaway from this chapter, then that should be a win. Also, none of these is mutually exclusive. Algorithms are frequently combined with one another, especially the last one. 1. Data label. This is where we describe raw data to provide the algorithm context for what the data is. 2. Model. This is the output of an algorithm run on data. 3. Supervised learning. This is where we have a labeled data set with the answers and we train the model to determine what is statistically significant. This is often used for forecasting and predicting future actions through regression analysis. 4. Unsupervised learning. We don't have labels for the data, so we're just using the algorithms to infer structure and labels out of the data by identifying clusters of data. 5. Reinforcement learning. This is an autonomous self-learning method that uses trial and error to learn from experience. Think of a Roomba that learns the layout of a room by simply mapping where the objects are located by bumping into them. 6. Neural network. This is a machine learning method to process data as the human brain would. It uses interconnected algorithmic structures, like neurons in a brain, to employ multiple models to learn and model complex data, input and output. 7. Deep learning. This is an autonomous self-learning method using neural networks that employs a large data set for training before it's applied to predict new data. Think of facial recognition on an iPhone that maps your face, the training data, and when you use your face to log in, it predicts whether you are you. In case you're wondering, the wildly popular ChatGPT uses a newer deep learning model known as transformers. Historically, when training a model to understand a sentence, the model analyzes text word by word. Now, transformers can process an entire sentence at once, making them far more efficient to train. It also makes use of large language models, LLMs, part of natural language processing. LLMs are a sophisticated way to process and infer the relationships between words in enormously large amounts of text. But how does this affect supply chains? At this point, I know you're thinking, enough of the jargon, get to the point. How do we apply all this fancy machine learning to supply chain problems? Each of these concepts is already used in supply chain management. Supervised learning is used for demand forecasting, spend data classification, fraud detection, and my personal favorite, data management. Unsupervised learning is used for market basket analysis, contract analytics, think clustering of clauses, and logistics optimization. Deep reinforcement learning is used with robots on manufacturing production lines and in logistics centers, think transporting, picking, packing, palletizing, depalletizing. We are well into the machine learning for supply chain journey. For us to truly build the next generation AI supply chain, we need to understand how to better make use of these algorithms and ensure they aren't directed against us. First, we need this level of understanding so that you can make better buying decisions when solution providers, consultants, and contractors try to sell you, quote, AI and machine learning, unquote. Here is an excerpt from a spam message I received while writing this chapter. Quote, to stay out of the curve, procurement teams must adopt a more innovative approach. They need to move toward the use of AI and machine learning to plot the complex variables involved in supply chain planning, unquote. Naturally, I am skeptical, if not downright dismissive, of statements like these. I want every supply chain professional to not only view these messages with the same level of skepticism, but also to be able to challenge back and ask them what kind of deep learning or reinforcement deep learning they use. This is the technique I use because it quickly separates the posers from those who know what they're doing. The posers will start spewing out more jargon. Those who understand machine learning will stop and clarify what they're doing, supervised and unsupervised versus reinforcement deep learning. The fact is that all of these take significant amounts of data to be relevant. Think mapping the entire human genome, which is way more data than most startups have. As you can see from reinforcement learning, deep learning, and reinforcement deep learning algorithms, they learn and act autonomously based on the data they ingest and how they interpret it. When there are multiple layers of data interpretation based on historical learning and data modeling, it can be nearly impossible to explain why two outcomes might be different. In other words, no core set of rules explains a particular action. A good example of this is Google's search autofill feature, which may offer you and your colleagues across the globe different autofill responses. Naturally, this is going to make it difficult to comply with legislation. Regarding third parties, this lack of standard rules begs some difficult contractual questions. If an enterprise uses a solution that gets smarter because of the data provided by the enterprise, is it entitled to compensation because it made the algorithm and thus the solution better? What happens when you stop using the solution? Moreover, who is liable if the solution makes a costly mistake? The most important reason to learn how machine learning algorithms work is so that you can understand how they can be hacked. As explained above, when Chinese tech companies put gamification into gig worker apps, workers game the system by putting in fake orders. This happens all the time on review sites and search engine optimization. If you want to sell a product and displace your competitor online, you don't need a better product or a lower price. You simply need to trick the search algorithm into prioritizing your goods over your competitors. In other words, data can be used to manipulate algorithms. We must appreciate this fact before implementing algorithms everywhere in our supply chains. Consider how many user consumption forecasting models will be skewed because of the pandemic. Look at historical data trends of airline travel, toilet paper, car purchases, and technology purchases. All were skewed by the pandemic. If you study the consumption data of any of these over the past 5 years, it will look very strange for 2020 and 2021, and possibly 2022. So how do you predict what will happen in 2023, 2024, and beyond? Every leader must understand and wrestle with these questions. The point here is not to solve that problem, but rather to reinforce the importance of data cleanliness and governance. The observant reader will rightly have deduced from the algorithm explanation above that machine learning can also be applied to data management with significant success. This is a whole discipline in itself. See my spider chart for some companies that do this. However, it also means there is no excuse for bad data or lack of data governance. How to learn more. I recommend playing with algorithms. Create a temporary social media or e-commerce account and watch how the algorithm customizes itself to you. Observe how it changes what you see based on how you interact. Even better, do the same exercise with a friend so you can engage in social-based learning. Or spend some time with ChatGPT and see if you can jailbreak it by circumventing its editorial controls. Engage with Siri, Google, Alexa, and see how you can use algorithms to hack your daily routine and squeeze out some more personal free time. Hacking AI, 5 takeaways. 1. Make friends with the algorithms in your life. 2. Explore the basics of machine learning. 3. Determine the 12 algorithms that will run future supply chains. 4. Study the impact regulations will have on using algorithms. 5. Put learning AI at the top of your to-do list.